This is Group 5's presentations on stock flows and monetary theory. It's a paper written by Baumol in 1962. So this paper in part 1 deals about double equilibrium conditions. This was first proposed by Bushell and Clower, and they said that in general equilibrium theory, it should employ two equations. The first equation being the flow equilibrium condition, the second equation being the stock equilibrium condition. So the difference between a stock versus a flow: a stock is a snapshot in time of any amount cast, where a flow is a variable that affects that measure of stock. And how to make sense of that, we're now going to talk about three types of flows when talking about a flow equilibrium condition. So the three type flows are production, consumption, and net addition of stocks. Assuming a competitive market, we can then draft two demand functions using those three flows. The first demand function is being the excess consumption demand, which is consumption demand D of C minus production supply S of P. And excess inventory investment demand, which would be the second function, demand for goods to be added to stock D of 1 minus supply of goods out of current stock S of 1. How will these flows, when will these flows be in equilibrium? Well, they'll be in equilibrium when the sum of those two equations equals 0. And the sum of those two, that formula, is then titled the flow equilibrium formula, right? So the flow equilibrium formula equals excess consumption demand plus excess inventory investment demand. And when that equals 0, then you have flow equilibrium. Now from this, we can derive the second equilibrium formula, the stock equilibrium formula, which is essentially demand for goods to be added to stock, D of 1, minus supply of goods out of current stock. This should sound familiar already because it's the exact same formula as the excess inventory investment demand. It's the second part of the flow equilibrium formula. So the second part of the flow equilibrium formula equals the stock equilibrium formula. Part 2. The Pigovian dichotomization argument. Initially, Pigovian argues that you can't split the economy in two sectors, and the reason for this is Walras's law, which states that the sum of all excess demand across all markets is 0, and it's in equilibrium. And because of that, the flow and demand of the money supply must also be equal and in equilibrium, 0. So more on Walras's law. We don't have time for this when I recorded this. We're going to skip that. So some people believe Patinkin's argument is flawed, that you can divide them into stocks and flows. You know, crazy enough, Bushell and Clower, the first people to discuss, believe that. And that's why they have their stock equilibrium formula and their flow equilibrium formula. But Baumol says you don't really need the two anyways, right? So let's for instance think that the money supply is fixed in an economy, right? The money supply is fixed. The result of the net production, which is D of C of S of P equals 0. If you recall, D of C minus S of P is an excess consumption demand equation, which is also the first part of the flow equilibrium equation. If we can then drop that because it's worth 0 from the flow equilibrium equation, we're only left with the second part of the flow equation, which is identical to the only part in the stock equation, meaning that both the flow equilibrium equation and the stock equilibrium equation are identical, they're the same, right? So when the money supply is fixed, you only need the stock equilibrium equation. If the money supply isn't fixed, then you can't drop the excess consumption demand because it's no longer 0, which means you have to leave it in that formula, which also then means that excess inventory investment demand, the second part of the flow equilibrium formula, is now only reacting to changes in the excess consumption demand formula, the first part. And because of this, you have to use the full flow equilibrium formula to get any kind of guise as to what the market's doing, you know, if it's in equilibrium or not. If you look at only the stock equilibrium equation by itself, it's kind of pointless because it's only giving you half the picture, because it's not letting you see how it's affected by the excess consumption. So now we're going to go into liquidity preferences versus loanable funds. So first, we're going to define those using operational terms like how Baumol does. Liquidity preferences in the short run: interest rates must satisfy both the goods market and labor market equilibriums through the money stock equilibrium condition. Loanable funds, however, in the short run, the rate of interest must satisfy the bond flow equilibrium condition. The real theory's idea is that in the short run, the rate of interest needs to satisfy both goods market and labor market flow. It's kind of a general thing. And all of the three of these theories are used to kind of pick the best interest rate for the market for it to reach a happy equilibrium. So in order to kind of delve into this further, we're going to divide the market into 4 separate sections: the bonds, commodities, money, and labor, right? pretty simple. In the short run, using the loanable fund mechanisms isn't really a great idea. The bond market tends to reach equilibrium first just because of the nature of how fast stuff moves. Supply and demand, it varies a second there. In the short run, interest rate needs to act as a security inventory equilibrium insertion to allow people to buy and sell. Basically, the short run, the interest rate has to just modify the stocks. It can't modify the flow because there's not enough time to modify the flow. In the intermediate short run, though, when there's a little bit more time, the loanable fund mechanism, which is based upon modifying flow, can function because you can adjust the flow of bonds in and out of the market. For liquidity preferences, though, in the short run, it doesn't work either because if the bond market is in equilibrium, then it says the money market should be in equilibrium too. But that's not the case because, as we see during depression, when the bond market can reach equilibrium, we can have an excess supply of both commodities and labor, which is usually accompanied by a resulting excess demand for money. So nothing's in equilibrium there, really. In the intermediate short run, Baldwin doesn't really say much on what the liquidity preference will say, other than that there isn't enough kind of information out there to really gauge what it would do. In the appendix, which is the fourth section of this paper, excess demand for stocks, Baldwin talks about kind of the second equilibrium equation, the stock equilibrium equation, and issues he had with that, and kind of how he flip-flopped on that a little bit. So know about equation 2. Recall that equation 2, D of 1 minus S of 1 equals stock equilibrium. And typo here, stock and flow need to be flipped. Baldwin isn't a fan of this because it's using variables from a flow equation from earlier to determine the stock equilibrium, right? Which doesn't really make sense. Anyone can figure that out. And could there be a relationship between stocks and flows that could justify using the flow variables to derive the stock? Possibly, but Baldwin says if there is one, it's going to be non-existent. It's only going to be that they intersect at the y-axis and they both point in the same general direction. And Patinkin disagrees with this a lot. Patinkin thinks these are going to be identical, these two formulas were correct. So more on what Patinkin thinks, I'm probably saying that wrong, by the way. If you look at the two equations, you also have to add two constants. And both these constants are that they have to be analyzed in the same reference period, and they have to be identical in terms of how much money or how much you're measuring, right? If you're going to measure $12 billion in one, you have to measure $12 billion in another. So for instance, if someone wants to get rid of $12 billion of stock over the course of 3 months, you will also see an outward flow of $12 billion over those 3 months, right? So in that essence, they're going to be identical. Baldwin says, you're not wrong, dude. If you look at them when they're both in these identical situations, and yeah, they kind of do mirror each other. But he goes on to state that he doesn't like the idea of calling the second equilibrium formula the stock equilibrium formula. Instead, he thinks it's better to call it the flow production equilibrium formula because it's derived from the flow variables and not its own stock variables. So now here's our discussion questions. In what situation are two demand equations from part 1 not legitimate? Do you think Baldwin is right in believing that the two formulas represent flows only? And is Walras' law holding true in today's market?